actually record these questions. So before we get to that, Sophie, do you want to continue with the rest of the model?
Sure. So now I'm going to go over to the preservation tab, and you'll be happy to see that it's almost identical to the green building tab. So we base this worksheet on the green building so that the comparison would be really equal and fair. So you can see again, it's divided into the retrofit and the one-time emissions, this time from the retrofit instead of the construction. And then on the right-hand side, again, we have the operations. So the same thing, are you going to disturb the landscape? Are you going to install any new landscape? Remove trees, install trees. Again, you have the embodied energy of removing something from the existing structure. So this time, you're probably going to be removing less because you're hopefully trying to preserve as much of the existing structure as possible. And then we go down here, and we have the emissions from the retrofit. So again, what are you adding to the building? So, for example, in this case, we would be adding a whole new roof or fixing up the foundation or things like that. So everything that we're adding will go here, and you see in cell D39, again, it calculates the CO2 emissions from adding those materials. You'll see a couple of differences here on the energy side. The average energy consumption is calculated in the same way, but this time you have two options. You have decreased efficiency and added efficiency. So this is just giving you a little bit more flexibility. One thing that we learned about preservations while we were creating the model was that decisions are not made based on how energy efficient they're going to be. So you're not necessarily going to put in triple paned windows into a preservation house. So in this case, it could be actually less efficient than an average building that's built 30 or 40 years ago. So we can say it's 30% less efficient than average, it's 10% less efficient, or conversely, it could be more efficient than average. So we wanted it to be flexible. So if you're not necessarily doing a historic preservation, but you're just restoring an older house, you could be putting in those ultra-efficient windows or insulation, and you could have a house that is more efficient than average. So we wanted to give you both options there to make it as flexible as possible. Again, you pick the state, and you get the emissions coefficient. And here you have the expected building lifetime again. And I know it could be tempting to say that, well, the preservation is has a really good foundation, it's going to last longer than the green building, and you want to put in a different number here. But the point is really to put in the same number so that you're comparing over a certain number of years. So finally, you come back to the dashboard, which probably makes a little bit more sense now. It brings together all of those numbers, and you can see just really clearly that we have the green building emissions, the one time, the per year, and then on the 50-year basis. Same thing for the preservation. And then over 50 years, the preservation would have, for the numbers that we have entered in there right now, 760,000 less tons of carbon, and we could see that over 99 years, they would be the same. So this graph really shows that. You can see that the red line would be the green building, and it has, at year 0, it has significantly higher emissions because you have the demolition of the new building and you have a lot more construction materials coming in. So the emissions are much higher than the preservation, but it increases at a much slower rate than the preservation because it's significantly more efficient. So you can see here around 99 years is where they cross, and that could help you make a decision. So if that were much closer, say in 20 years, you could say, wow, it's not that much cleaner to do this preservation, so maybe we need to look at our preservation and how could we make it more efficient, or maybe this is not the best option for this particular house. So if there's any questions right now about how the model works, I can take them. Otherwise, Mike is going to jump into the 65 Pleasant Street example.
May I ask Mike a question? Sophie, incidentally, I saw Bruce Coldham try to do this at Nessie this year, and he left the room and everyone was in tears. And he was referencing Bath and other instances in which people have developed these models. I think what you've done and explained is really, it's terrific. And I hope that you guys don't disappear so that maybe we can get you to come to Nessie next year and develop this model in front of people.
Well, were they in tears from laughing or crying, Henry?
I think people were in tears because it was so incomprehensible and so badly taught, so to speak.
That's not good. Well, I mean, honestly, the question is probably best reserved for Sophie. To be totally clear, I've done remarkably little, which will not surprise Christian at all. But this is something that this team has really come up with, and I've just done my best to represent what limited knowledge I have about, for instance, certain decisions in preservation, like how it would be very difficult for us to take perhaps existing 6/6 windows, well, maybe single-paned, we wouldn't want to get rid of for a nice vinyl-wrapped triple-paned window. So that having been said, the presentation and I think the organization and the thought behind this is entirely Sophie and teams. So I don't know. I hope it doesn't disappear either, because I'd like to actually take some refinements based upon your questions and see if we couldn't attempt to maybe advance this a little bit further. Accepting the fact that it'll never be perfect, but it is certainly a way to analyze this sort of interesting intersection between preservation and green.
Well, you are advancing it, because every iteration I see moves the point of indifference way farther out. I think the first time I saw it was 82, and now it's 100.
Well, I might have changed some of the numbers inadvertently in there, and we'll get a more accurate number when Mike goes through and checks the numbers. But just to add to Mike's point, our goal with even doing this webinar and writing up the reference guide is that we want to have as many people as possible be able to use this model. And you can see in the reference guide on page 13, there's quite a few things that we would like to see done to make it more accurate. And we could some of us are staying at school, some of us are graduating, but we're definitely interested in doing work on it in the future. There's one other thing I just wanted to point out, in case anyone is interested in seeing sort of the back end of the model and how this all sort of comes together, where do these numbers come from, and if you wanted to make any changes or play around with it, I just wanted to quickly show you how to do that. So if you had your own version of the model open, you might have noticed that you can't click anywhere, and that's because the worksheet is locked. We've made it so that you can only click in the cells that are supposed to be changed, just for ease of use. But if you did want to make changes, you would first go on each sheet, you would go into Unprotect Sheet, and there's a password for that. The password is 1772. Should be pretty easy to remember. So if you wanted to play around with it, you could do that. And all of these numbers, they come from a lookup table, and those lookup tables are on other sheets that are currently hidden, just to make it really easy to look at. So if you just go to Unhide, you can see all of these tables where the data is kept, and those are all referenced in the reference guide as well, so you can see where the numbers came from. And here you could see, for example, these are the numbers for the carbon storage capacity. So you can just see where those things come from and what the assumptions are behind the model. And with that, I'm going to let Mike run through the example so we can stay on track.
And actually on that, we have till only a few minutes left, and I really do want to take the time to solicit some questions. I know, Christian's on the call and is very familiar with other carbon calculators that exist. And so the idea behind our effort at 65 Pleasant, trying to scroll over here, we are actually in the midst of doing a existing conditions analysis, because obviously this house was built a long time ago, so it's not like it was built with oriented strand board and stud walls that are on 16-inch centers and very traditional insulation. So as we discover it forensically, I think we can actually come up with a relatively decent manifest list of materials, based upon what we see and with the help of the North Bennett Street School identifying it. But the purpose eventually will be, again, is to come through and for me to say on our footing and foundation wall, which is actually a scope of work item, we know that to replace 300 square feet of bulging foundation. So the input is as simple as that. And then, what material I use, unfortunately, I'm limited in this case to concrete block or cast. It doesn't involve, fieldstone. But what we will continue doing as I get better information about what 65 Pleasant Street is made out of, entering in the composition of the actual specific materials. So I know I need to replace some of the intermediate floor, some of the walls, and for instance, I know the roof, most of it has to go. Obviously, it will not be a 412 pitch with WSP decking, a hip roof, and we'll be using probably a cedar shake material or whatever else is appropriate as identified by our. That obviously will have a very different carbon consequence than the asphalt shingles are more traditionally used. So the demonstration, to begin, basically you've seen sort of how it works. A person like me would go through, would say, okay, I know how many square feet of this I have to input, and is this. And I'm sorry for that continued beeping, incidentally. That should stop shortly. Additionally, materials like bricks. Is that us? Is there any way to stop that? 1 second, please. Oh, that's just terribly annoying.
I think it just is an indication that the phone is being tapped.
That, or maybe it's talking. So that being the case, I really do want to have a chance to open this up to questions. I think that you get the sense of sort of how, from an operator's perspective, this can be used. So the 65 Pleasant Street example is more or less loaded into this with the data we have so far. Our wish list of what to make this better would be definitely to include materials, somehow getting a sense of materials calculations for things like the fieldstone foundation, which we do not have. Additionally, expanding the list, because I currently have 10 fields with which to choose, and expanding that so that I could have maybe 20 or 30 to get even more granular detail. And with that, I suppose, going back just to the dashboard and this idea of your indifference, if we can get any hard questions, if you don't feel comfortable answering over the phone, we can take it by email as well. But just as long as you have Sophie here, it'd be really good to hear feedback.
Well, I'd like to tell you how elegant I think it is, because it seems like something that maybe a historic preservation officer at the state level would be able to learn how to use. And I think that's tremendously important. So I love the fact that it's elegant and very easy to understand. And I think you made it easy to understand because the writing in the reference manual, too, was crystal clear. And so that's just some feedback on the project part of it. And I like the fact that you chose the decision point to start with, because that's where it matters. That's where all this information matters. I just thought it's wonderful. I think it's great. I mean, I'm just kind of blown away by it, actually. We've been hearing about how preservation is the greenest choice, but I've never seen it laid out like this before.
Well, that's good to hear. I guess the question becomes how to responsibly disseminate it with, how do we get it out? Number one, would it be ready for a release within the preservation community? Obviously, I think there needs to be refinements to it. But then, to make it operable, it is certainly elegant, and I think the team did a great job with that. But what are the additions that are needed, and more importantly, what are the qualifications that are part of this to sort of make this say, this is a view, and it is an informed view. It is not, 100% perfect. So, on those notes, does anybody have some observations on where it perhaps could use improvement?
Mike, this is Christian. Sophie, I think this is a great looking model, and as Mike had mentioned, I've seen several of these, but most of them that I'm familiar with have been for operating large commercial buildings and more geared towards the operation side, not as a comparison of a build versus a preserve question. I'm curious, do you factor in here any loss of efficiency over time? And as we notice in commercial buildings, they'll drift from what their original design is. And I don't know if you've accounted for that here, or maybe it's not even applicable at all, but I was just curious if that was anything that came up in your conversations.
Actually, we haven't accounted for that, but that's a really good idea, and it wouldn't be too difficult to just put in maybe a little curve so that the efficiency decreased over time.
For both?
Henry, did you ask for, if we could definitely do it for both, if that was the question. And I think
that was.
Also, the curve would have to be of a different nature, both for obviously a building with newer systems and better, more thoughtful layout with HVAC design, as opposed to, us just taking 65 Pleasant Street and installing the best water heater we can find.
It also, because it's based on the average energy consumption of a certain size house in a certain region, it also assumes that that's something that's going to stay steady, which isn't necessarily the case either.
Nor is the composition of the energy supplies. I mean, if Cape Wind takes off, for instance, what percentage of Massachusetts' future will be wind energy as opposed to our heavy reliance upon coal or oil heat? And so I think that